Solve the differential equation d square y by dx square plus 4 times dy by dx plus 4y equals sin h 2x. We have the RHS, which is hyperbolic sine function, and it's a non-zero function on independent variable x. Hence we have a non-homogeneous type of differential equation whose general solution will be CF plus PI. In order to find out complementary function, we have f of d equals d square plus 4d plus 4 rewritten as capital D when replaced by m. We have auxiliary equation obtained as m square plus 4m plus 4 equated to 0. The auxiliary equation has two roots, m1 equals m2 equals minus 2, which are the repeated roots. Hence, the format of complementary function will be c1 plus c2x e raised to minus 2x, or you can write it as capital A plus capital Bx multiplied to e raised to minus 2x. Now we have to find out particular integral. We have sin h 2x also written as e raised to 2x minus e raised to minus 2x upon 2. Therefore, particular integral will be evaluated as pi1 and pi2, where pi1 equals 1 by 2 times 1 by f of d acting on e raised to 2x, and pi2 will be 1 by 2 times minus 1 by f of d acting on e raised to minus 2x. Or you can consider pi2 equals minus 1 by 2 times 1 by f of d acting on e raised to minus 2x. We have f of d equals d square plus 4d plus 4, and hence 1 by f of d will be the operator 1 by d square plus 4d plus 4, which acts on e raised to 2x as well as e raised to minus 2x. Let us compute pi1, which is 1 by f of d acting on e raised to 2x. Whenever we have RHS equals e raised to ax, where a is the coefficient of x in the power part of exponential function, we will give capital D equals a in f of d, which appears in the denominator. That is, wherever d appears, we will replace d by a, which equals 2 here. Thus we have denominator becoming 2 square plus 4 times 2 plus 4, which becomes 16, and since the denominator is non-zero, we have pi1 equals 1 by 16 multiplied to e raised to 2x. Now let us compute pi2, which is 1 by f of d acting on e raised to minus 2x. Here we have a equals minus 2, which is the coefficient of x in the power part of exponential function. When you give capital D equals minus 2, you obtain minus 2 the whole square plus 4 times minus 2 plus 4, and since this is a 0 value, by the rule to compute pi, we will multiply the numerator with x, and we will take the derivative of f of d with respect to d in the denominator. That is, denominator now becomes f dash of d. We have f dash of d equals 2 times d plus 4. In the expression of f dash of d, now we will give capital D equals a, and we will check whether the denominator is non-zero. We have f dash of d at d equals minus 2 becomes 2 into minus 2 plus 4, which is again 0. Since f dash of d at capital D equals a equals minus 2 becomes 0, we will again have another x multiplied in the numerator, simultaneously taking derivative of f dash of d with respect to capital D in the denominator. We have f dash of d when taken derivative with respect to capital D becomes f double dash of d equals 2, which is a constant, and hence at capital D equals a equals minus 2 also, we have f double dash of d equals 2. That is, f double dash of d at capital D equals minus 2 is 2 itself. Hence we have denominator, which is a non-zero value obtained. So pi becomes pi2 equals x square by 2 multiplied to e raised to minus 2x. Our general solution will be cf plus 1 by 2 times pi1 minus pi2. Thus, general solution equals c1 plus c2x multiplied to e raised to minus 2x plus 1 by 2 times e raised to 2x upon 16 minus x square e raised to minus 2x upon 2.